Why on earth would I need a detailed 3D model of my dial indicator? Stay tuned and find out. Welcome back to Cloud 42. I'm James. Today I'm starting a new project for the lathe. When I use a 4-jaw chuck on the lathe, I often use a dial indicator to dial in the workpiece for zero run out or to dial in a face that I need to register. And I can do that with an ordinary magnetic base and an articulated arm and a dial indicator, but it takes time to set up and it takes a little bit of work to get it on center. And what I would really like to have is just a tool holder that fits in the tool post on the lathe that I can just drop in, know it's on center, do my indicating, and then take it out and keep working. So just for clarity, this is my lathe. I've got a piece of stock chucked up in here, just a piece of scrap aluminum. I've got this in the 3-jaw. I didn't bother putting the 4-jaw on. I'm just trying to illustrate this. And this is the way I would normally use a dial indicator. Magnetic base goes down on the compound, and then I've got to maneuver the indicator into position to get what I need. And I got to make sure it's on center. And then I can bring it in and I can indicate. And you of course can't quite see that because of the glare. Try to get in a position where you can see it. There. So then I can dial in with the compound and watch the needle. And if I want to do the face, then I've got to flip this around like this, rotate the indicator, and then I can do something similar to indicate the face of the part. And this works well enough, but I've got to mess around with this indicator holder and I've got to get it out and put it away. Now what I'd really prefer would be to make a block that just drops right onto the tool post holder that has a dial indicator in it. I've got this HHIP indicator. This is a small face indicator so that it's more compact and can fit into this space better. And ultimately what I'd like to do is make a block that holds two of these, one facing out one direction and one facing the opposite direction, so that then I can put it on the side and use the indicator here to do radial run out, and then I can flip it around, stick it on here so that the indicator that was previously on the back is then sticking out the side and I can indicate the face. And so that's what I'd like to do. Now, again, there's lots of people that have designed these. I know Mr. Pete did a number of videos where he made them, and the way he did it is he had them attached to the lug on the bottom, more or less on the side of a block that was relieved a little bit. I'd like to take this a step further and overdo it, which is sort of the way I usually do things. And I'd like to CNC machine a holder that fits nicely around the indicator, that doesn't add too much bulk, but that looks nice and functions well and has smooth edges on it that are nice to handle. And that's going to require modeling. And to model something that's a very tight fit around this indicator, I'm going to need a 3D model of the indicator. So let's go over to the surface plate and take some measurements so that we can make a 3D model of the indicator so we can use it as a reference designing the block. Okay, this is the dial indicator that we need to measure so we can model it. Now, there's lots of measurements on this I can just take with a caliper. I mean, I can get the diameter of the body, I can get the diameter of the face, but there are also lots of things on here that are really difficult to measure with a pair of calipers, like to measure exactly where this cylinder is coming out of the side of this other cylinder and exactly how long it is. And these kinds of things are tough, but the easiest way to measure a lot of this is just with the surface plate and a height gauge. So let's start with just a rough diagram of this. Let me just draw the shape of it. So we've got the outside bezel. I'm looking at it from the back side here. So we got the outside bezel. There's a little lip, and then there's the outside, there's the bezel, then there's a little lip, and then there's the body. So there's another circle just inside this. and then the body is inside of that. Then there's a cylinder that comes out here, and then the tip. And that's knurled. And then on the back side, we have similar situation, cylinder that comes out. And these are all things that we can measure. Looking at it from the side, and then on the back, of course, there's something in the center here, and then there's a lug. Looking at it from the side, we've got that same ridge. We've got our cylinder that comes out, the same tip on it, and the same thing coming out the back side here. Okay. And then, of course, we've got the lug raised in the center. I'm going to abbreviate it there. And that's probably enough to get started. So let's start by measuring the overall height of this back. Let me make sure that my dial indicator is zeroed. Okay, that's 0. So the height of the back of this thing is 0.787 inches. So that is this height here, 0.787. The height to the ledge there is 0.265. The height of this ledge .223. And so those are the basic dimensions on the back, and we might as well go to these other points as well. 0.818 to here. And to the top of the lug. 1.530. Now, let's try to figure out exactly where this cylinder that comes out the side fits. And the height gauge is actually a really easy way to do that, because I can take a measurement from the baseline to the top of that cylinder quite easily with this. And that measurement is 0.720. And then if I couple that with the actual diameter of this, which is 0.373, that's going to give me all the information that I'm going to need to figure out where the center line of that is, because it's going to be this 720 measurement minus half of this 373. Okay, let's get some diameters on the back here. This one's not super critical because we're going to end up taking it off, but I want to model it anyway. 627. Then the body, 1.418. And the step down here is 1.516. And the overall bezel is 1.588. Okay, so we've got the diameters of the back, we've got the heights of each of those registers. We've got the height of this. We don't have diameters on the back side here. So the narrow diameter of the stem on the back is 287. This larger diameter on the back, 0.316. And the tiny step on the back of the tip here, 286. Stem on the front, 157. $170 here. Okay, so we've got the diameter of that. There's a chamfer here. I won't bother, I'll just do that by eye. Got the heights. Okay, so now we need the lengths of these things. So where do we want to measure this? I think the best place to measure this is from where it comes out of the body here to the tip. And we can measure that with the step jaw of the caliper. 606. And we can measure from that step to the end. 655, that's from here to here. We can take these measurements kind of in a variety of places. The end of the stem to just below the tip looks like 425. And the length of the knurl down here, as if it mattered, is 125. That makes sense. See, is there anything about those links that we're not going to be able to get? Nope, I think we just need them on the back now. Let's see. What else am I missing here? Ah, the hole here. How big is this hole? And just approximately, we're looking at, looks like 261. And then what is the width of the lug on the back? Need to know that as well. 620. And we know about what that hole is, but we don't know what the height of it is. Let me get some drills here. Whoop. Okay, so there's a drill that just fits in the back, and we can measure the height to the top of that to locate that hole. And that looks like 1.342. Incidentally, what's the diameter of that? 260. And we estimated that was 261. That's close enough. Okay, what else do we need to know? Let's take the back off and get a measurement of what's going on back here. Looks like 50 thousandths. And that means that there's also, if you can see it, there's a little bit of a recess in the back here. We need to know how far that is. And I'll just use the tail of the calipers to estimate that. 21 thousandths. And the diameter of the recess on the inside, 1.37. Okay, and then the diameter of the back itself, 1.35. Okay, the only thing left are the holes in the back that I can see. I'll remember some more things later when I'm trying to model. And so what we need to know is how big is this hole pattern, because this is the hole pattern that's actually on the back of the dial indicator. And this is the hole pattern that we're going to need to use when we attach it. So I need to know how far apart those holes are. And I'll just use the holes in this to estimate that. So what I'm going to do is I'm going to measure over the outside of these holes and over the inside of the holes. And I'm going to record all those measurements, and we'll use some averages because this is probably not a very finely machined part. So min, max. So let's just measure the minimums here, and I'm just going to measure across the inside of the hole like that. So 714, 716, 712. Let me write these down. 714, 716, 712, and 713. And on the plus side, if I use the inside jaws, 903, 905, 904, 904. So if I take the average of all 8 of those numbers, I will get the actual distance center to center between these holes, and then I can lay out an identical pattern. And let's see how big the holes are. This is just going to be rough. 97,000. Those are metric, and we'll figure out what size screw this is just by testing with some different screws, and we'll figure that out. I'm guessing that's metric, and I'm guessing that's M2 or M2.5. We'll try them and see. I think that is about all the measurements we need. When we go into the computer and start modeling this stuff, anything else that I discover that I don't have that I need, I can easily just grab with calipers or run back out here to the surface plate and use the height gauge and get another measurement. But I think that's all we need. Let's go into the computer and draw this thing up. Okay, here we are in Fusion 360. Let's model up this indicator. And we'll just start with a new sketch. And I usually start on the XY plane. And the reason I start on the XY plane is because if I'm going to be milling or if I'm going to be 3D printing, the XY plane is the bed of the printer, or the bed of the milling machine with Z coming up from that. So if I'm drawing the outside perimeter of my part in the XY plane, then I already have it oriented correctly for printing or for milling, and I don't have to do anything exotic to get it in the right position. Okay, so I'm going to start out with basically the circles that we measured. I'll hit C for circle, and I'm going to draw a few circles here. One for the tab on the back, one for the body, one for that first ledge, and one for, whoops, that wasn't centered, one for the outer knurl. And then I will come back, hit D for dimension, and dimension these up. So the center of this was 0.627 inches. The actual body of the indicator was 1.418. Then the ledge around that, 1.516. And then the outer knurl of the indicator face itself was 1.588. Now that gives us the main structures of this. So I'll stop and I'll just start extruding. So I'll take the center here, extrude that up, and the full height of that was 0.818 inches. Now that sketch has disappeared, so I'm going to go over here and turn it back on. Then this will be the body of the indicator. We'll extrude that up, and the full height of that was 0.787. Then the little ledge around this, extrude that, and we measured that at 0.265. And then the knurl, the actual bezel around the outside, extrude that, and that was 0.223. Okay, so just that quick, we already have the main structure of the indicator. Now I don't need that sketch anymore, so I can turn it off. One thing I did not measure when I was at the surface plate was the recess in the front, and I'm going to actually go ahead and create a sketch here and put a circle to sink that in. And I measured it again with calipers when you weren't looking, and the dimension of that was 1.38 inches, and then that was sunk in 0.068, 68 thou negative. That didn't work because this needs to be set to cut. Okay, so that's the front, and then we'll go ahead and put a couple of chamfers on that. Okay, so that looks about right. I'll buy that for the dial face. And so the back of this is structured. Now the next thing we need to do is actually put the cylinders that come out the sides, and we're going to need a place to put those sketches. So I'll go over here to Origin and find a plane that makes sense. Let's do the YZ plane, and we will create a sketch on that. Now we need to put in a circle someplace, and this circle needs to be horizontal to the origin. And then the question is, how far up? Now we know this is going to come out the side, and we know the diameter of this thing from the measurement we took was 0.373. But how far up is it from the bottom? Well, it's going to be, we measured to the top, and that was 0.720 minus half of this dimension. So I just click on it and say divide by 2, and now that's positioned in the correct place. Now I'll right click here and hold it for a moment, and then choose Profile, and then right click and say Extrude. And we're going to extrude this out. We don't want to cut, we want to actually join. Now how far do we want to take that? Well, we know that it is 0.606 plus the radius, because we measured it from this surface. And so the radius of that is 1.418 divided by 2. And there we have it. Now to continue, this is the end with the indicator. We'll just go ahead and create a sketch there. Put another circle, snap to the center of that. And we know that the diameter of that is 0.157. And then stop, extrude that. The length of the next part of the stem, which is 0.425. And then we'll just continue, just following the same pattern. So we create a sketch, circle, the next diameter here, we measured at 0.170. And then we'll come in and grab both of these regions. Extrude that out. And the width of that is 0.125. Again, as measured. Now this last one is going to be a little bit tricky because we need to rotate and make a cone shape. And so the way we're going to do that is we're going to create an axis through this cylinder. So that gives us an axis through the center. We're actually going to want this later, so this will be handy. And then we're going to construct a plane. So we'll say plane at an angle. Click on that, it's at 0 degrees, and now we have a plane, and we can right click on that and create a sketch. Okay, P for project. I'm going to project that line on there. Okay, C for circle. I'm going to put a circle here. Now I want to make sure that this circle is centered, so I'll select that and this point and say horizontal vertical. That'll make sure that it's centered on that line, and then I'll do a line from here to tangent to that point. Now how long is that tip? There to there is going to be 105 minus that divided by 2. Let's go ahead and bump this up. This doesn't look quite right. Yeah, that looks better. Okay. I need to make sure we have a line from here to there. And now we should have 2 regions, so we can select, create, revolve around this, join, and now we have a tip on our indicator. Okay. Now we'll do exactly the same thing to come out the other side of the stem. Create, revolve it around this line, join, and now we got the back of that modeled. So now this is really starting to look like a dial indicator. The last thing we need to do that I can see right here is we need to put the actual lug on the back. So let's do that with a sketch in the vertical plane. Let's do it that way. Let's find the right plane here. Create a sketch on this. I'll project this surface, and then we'll sketch a point just so we know exactly where the center of this thing is. Put a circle up here aligned with that point. Another circle for the center of it. And let's see here, the dimension of the outside of this, which we measured earlier, was 0.620. The dimension of the inside was, what did we decide that was? 0.261. And then we want a couple of lines that come up tangent. Okay, and now we just extrude this, and we're going to take this one 2 sides. Nope, let's say symmetric, and the measurement is going to be over the entire width. And the entire width of that, which is something I didn't grab when I was at the surface plate, but I grabbed it later, is 0.242. Okay, so there we go. Now you can see that's a little bit wonky because I'm on a round surface with a rectangular parting here. So what I'm going to do is I'm going to come in here. See if I can get where I can see this better. Trying to get to where I can see up underneath this and grab that space. So what I've done here is I've grabbed the profile by which that extends over the side, and I'm going to say create sweep. So that profile, I am then going to sweep it along this path. And what that'll do is that'll take it around the side and create that rounded shape. It's cut by default. Click, and there it is. And I need to do exactly the same thing for the other one. I think I can select through. If I click here and hold, I can click that face. I can select that face that's underneath, and then do the same thing, create, sweep, the path is going to be around that edge, and it'll cut that off and make it curved, exactly the way I want it. And I'm just realizing I never did separate the back from the indicator, so I've modeled this all in one piece, and that is not exactly what we want. So let's go ahead and fix that. I know that the back of the indicator, so if I click here and say construct offset plane, I know that the thickness of the back of the indicator is 50 thousandths, so minus 0.050, like that. Now I should be able to take this body, say modify split body, and I'll use that plane as the tool, and now I have two parts, a back and a front. Now let me go ahead and turn off let me go ahead and label these. This is going to be the back, and this is going to be the indicator. Okay, so let's turn off the back for a minute, and let's look at the indicator here, and we know, turn that plane off, that there was a ridge around this thing. And we know inside that ridge was 1.370. We know the ridge was 21,000 steep. Okay, so now we have the back of the indicator with that ridge on it. Now let's go look at the back itself. Create a similar sketch here. And let's do a couple of things here. One is we're going to cut this down to the correct diameter, D for dimension, and we know the diameter, that is 1.350. And the other thing that I want to do is I want to put in the holes. So I'm going to do a couple of construction lines, L for line, do that, another one here, and these are just for mirrors. And then we'll come out here and we'll put a circle. Whoops, not construction. And what we'll do is sketch, mirror that object around this line, and then we'll do another sketch, mirror both of these objects around this line. So that gives us 4 of these that are going to move together. Now if I average up my dimensions that we measured for these things, I know the distance here needs to be 810 thousandths. That was the average of all of the other measurements we took. Now that pins it down so they can only move this direction, and I'll just do exactly the same thing here. And then I'll set the size of these holes. And the hole through here, I think I figured out, was 92 thou. Okay, great. So now I can just hit this and select all of these regions. Extrude. And we'll just cut all the way through. Okay, and that gives us a back with the holes in it. Bring the indicator back and you can see how that fits. Last thing we need to do is we need to put the holes in the back of the indicator here, the screw holes. So we will create a sketch here. We bring the back here and we will project the back of the indicator onto it. And then we're going to put some sketch points at all of these locations. And I think maybe the projected points would have been fine, but now we have that. Now we're going to create some holes. Where's my hole? There's my hole. Okay, we'll do the point here, and we'll just select all the points where we want the hole. And these are going to be threaded. And depth is going to be, I think I figured these out, 0.157 inches deep with 1 decimal point, not 2. And these are going to be isometric threads. Size is 2 millimeter, M2 by 0.4, right hand, and don't need to be modeled. Okay, so now those are the holes in the back of the indicator. Now there's actually some opening in the back of the indicator we don't care about, but there's the indicator, here's the back. I could go get some screws from McMaster Car by inserting McMaster Car component and put those into the model. So I think that's as far as I'm going to take this model. I actually did another one earlier that I took in a little bit more detail, and I've got some 2-width chamfers and went through and applied textures and knurling and tried to make this just as accurate as I could possibly make it. And you can see I've got some bevels on the base here. And I think this is the model that I'm actually going to use. I applied some color as well. I think this is going to be close enough for what we need, probably way closer and way overkill for what we need. But this is a good example of how you would take a physical object that you have and create a model so that you can then incorporate it into a design. So I think this is as far as we're going to take it today. The next step, of course, will be to take this model and use it to design the indicator holder itself. And we're going to do that next time. If you are enjoying these videos or find them useful, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.